In this video we're going to take a look at the BitsNBytes challenge on HackTheBox. It's a hard Stego challenge, and the description says, we have intercepted an email sent by a terrorist cell. It contains only an image. Can you compare the modified image to its original and see if it has any meaning? So I've not solved this challenge yet, it's new to me. Let's download the files. And we've got two PNG images with 1.1 kilobytes size difference. Let's copy these over to our local directory. And let's go and do some basic file checks. We can have a look at the images here first of all. No visual difference, which you really wouldn't expect there to be with, you know, a 0.1 of a kilobyte size difference. In the last video I kind of explained a bit about how Stego, basic Stego works in terms of LSB, and how we can make changes to each pixel in an image without having really any visual impact on it. And there are more complex methods than that, but I'll not go over that again. You can check back to the last video if you missed that. Let's do some basic file checks then. So we'll start by just verifying the file type, and both are PNG image data, same size, RGB. Let's run strings -n10 on both of them. See if anything sticks out to us. Any strings of interest here? Okay. Alright, I don't see anything that we could use. Let's run diff. It's just going to tell us they differ. Okay, I suppose. Yeah. Okay, they're PNG images, so well, let's check the EXIF tool as well. Intercepted. Yeah, it's not going to show much for the PNG anyway. Okay, we could similarly check out foremost on the intercepted, see if there's anything in it. There isn't. Oops, remove output. Alright, so let's try and do some, let's try and run ZSteg and have a look with StegSolve at the intercepted image just to see if we can see anything. Right, I'll start with StegSolve. Intercepted. I mean, I'm not really expecting to see much because it's saying compare. We're not really doing any comparing here, so let's open the intercepted. Let's just scroll through color inversion. Let's go through the different planes. And we're looking just for any yeah, you can see that there, whenever we went onto the 6th plane there's just a pure line of white down here, but we'd need to compare it side by side with the other one to see if you can see that's just a pure line of black there. But it might just be the image. You do quite often find that the corners of images can be where you'd see alterations. Okay. And then some random color maps. Alright, let's go and have a look at the stereogram. And we could try to do the extracts, but let's not bother. Let's run ZSteg with all the options intercepted. And we're looking to see if it manages to extract any interesting strings here, or any files. But there can be quite a lot of false positives with the extracted files. Like you see here, PGP secret key, and subkeys and stuff like that. They're not necessarily valid files. Okay, I wasn't really expecting to see too much there. Let's try and look and see how we can compare these images. So let's go and Google here, compare two images, Stego. Here we've got steganographic comparator. This form compares two images, one with a hidden payload, one without. It can greatly enhance the difference. Alright, that sounds pretty good. Let's actually open that, and we also have the here Stego helper identification tool on GitHub. The diff method will compare two images pixel by pixel. That's sounding good as well. Let's try this one first. Steganographic comparator. We'll go and select the original, and we'll select intercepted. Want to enhance the differences, and let's submit the query. Might take a while to run. Okay. Interesting. So that doesn't look different at all. It just pure black. Let's file is 0 bytes. Okay. So there's no difference, I guess. Without enhancement, the differences are barely visible. Well, we did the enhancement. Let's try the Stego helper identification tool. Okay, cool. So it can either create, read, or analyze steganographic images depending on your mood. Don't try to create challenges with this tool. I'm dead serious. Okay. And it has LSB in most significant bit and X bit, which we could use other tools for anyway. But it's the Steg analysis feature that I'm interested in, which will hopefully detect. Oh, right now it only detects duplicate values in the color palette. Alright. Diff. Certainly find the hidden message. The diff method will compare two images pixel by pixel and output non-matching pixels with position and value. Alright, that sounds awesome. Let's grab this. And we'll do git clone. Cloning into shit. Let's go to it and try some of this out. So let's remind ourselves what we could do here. We could do the LSB stuff. Chooses random pixels and stores a message. Okay, nah, we'll not do that. Steg analysis, this is what we're going to do. Let's try and do analyze py auto and then pass it the Stego. Okay, this is unfinished. This is only going to do the color palette thing anyway. So let's just do. Well, let's try it anyway. Let's do Python analyze .. intercepted. Oh, we need to give it the auto. We get nothing. Try and give it strings. Okay. Let me try and use Python 2. Okay. Let's activate our source pyenv2 and then pip install matplotlib. Just install this quickly. Just going into a Python virtual environment here for this, and let's try and run that again. Strings, no module named. Please install pip install python tk. I think I have to install this apt-get. Alright, try it again. So pip install. There we go. Just one after another. That's how we. Oh wow, no module named pill. Pip install. Pill. It doesn't sound like something that's going to pip install. Alright. Is there a requirements thing here I could have just used? No, there's a Docker file. Python pill. Pillow. Okay. There we go. I just did pip install pillow instead. Alright, so that works in terms of getting the strings. Let's see what else we can do here. Let's go back to our options. We had the option to combine. Combine two images may yield interesting results. For example, combining a picture with steganographic messages inside with its original may uncover hidden message. That sounds like a good idea. So let's try and do sub first. So analyze.py combine. And then we need to give it the two images. So let's go back here. Let's give it. So it's gonna. This is gonna subtract our first parameter, which should be our original image, or does it matter? All right, we'll see. Dot slash original. Dot slash intercepted, and then we're gonna say dot slash out.png. Saving the output. Let's have a look at the output. Oh, look at this. We have our we have something down the side here, which looks like it could be. It looks like it could be Morse code, maybe. Looking at based on our previous challenges. What do you think? Let's rotate this. We actually, in our previous challenge, we used a script to automate the Morse code decoding. So we could try that. I'm gonna try and do this manually for now. Trying to get a close view of it. We'll just try and do a few characters here and see how it goes. Let's go to Morse. Let's do the translator. So we can enter something we want to translate into Morse code, or we can type in the Morse code. So let's try dot dash space dot dash space dot space dot dot space. Not looking good. Unless it's dot dash. No. Dot dash. It's not looking too good, unless it's something that would have to be rotated. Alright, let's move on from that for now. It does kind of look like Morse code to me, but we'll see. It could be something else. Oh, let's close that saving. We could also do the images XORed. Let's do that. In fact, we'll do that to out2. See how that looks. Okay, so it's not looking as promising. We have a couple of dots there. It's not looking as promising. Let's see what else we can do. So we also had diff as well. Certainly find the hidden message. Diff will compare image by image, images, two images pixel by pixel, and output non-matching pixels with position and value. If the images do not have the same modes, the original will be converted. Okay, so let's try and run that diff, and then we'll pass in our original and our. Alright, let's just type it in here. Python analyze diff dot dot slash original dot dot slash intercepted. We run that and we get a list of the mismatched pixels. Let's take a copy of this. I'm going to go back a couple of directories and pixel mismatch.txt. Save these here for now and return. Just see if there's anything else we can look at. Draw. This especially helps in challenges which were designed to be solved with StegSolve. Okay. We've got modify. We've got palette. If the color palette was modified, duplicate colors can be used to hide information. And then strings. Strings to grep flag. Well, we already did the strings, and there was definitely no flag within the strings. Okay. So, yeah, we've done diff. I'm going to have a quick look at this analyze draw thing. Let's make directory new, and we're going to do draw. Actually, okay, yeah. We'll do draw. And then dot dot slash original. Is that right, or did it just take the intercepted? It just takes the Stego, and then output directory dot dot slash new. So let's get rid of the original. It's saving all those different planes. Okay, yeah, that's pretty cool. So that we can go through those. You remember, I think as we were going through, remember we were going through these at the beginning of the video, and I kind of said it looks like there's something down here at the side. Well, that's also where that Morse code looking thing came from. So yeah, we want to have another look into that. Actually, we already looked at the Morse code, so let's look at this again. This was the mismatched pixels, and it shows the location of each pixel that's mismatched. We have 1, 3, 6, 7, 9. Okay, so it's not necessarily in any particular sequence here, and we can see that the difference then between the pixels, there's a 1 difference here, a 1 difference here. So it seems to be just maybe the least significant bit in each case, which is in this case 1 greater. It seems to be 1 greater in each case. I'm trying to see if is there anywhere it's 1 less. I can't see any examples of that. Seems to be one greater in each case. So let's see what we can do here. Let's also have a look at the images that we extracted. Okay, we already have the. Oh yeah, let's go back. Let's look at the images we extracted and just see if there's anything we can do in terms of with the Stego tools with this as well. So it looked like this was, as we were saying there, maybe it's, the least significant bit or something. So now that we've extracted that in terms of our out.png with this down the side, let's try and see if we can run some LSB Stego on it. We can use ZSteg to basically run through all the checks. If we pass that in and try out.png, and it looks like we've got a base64 encoded string here, which you can see is taken from the LSB, and it shows you the what we can use to extract this. Obviously we can just say let's echo that to base64-d, and there we get a flag. That was nice, I liked that challenge. Let's try and submit it, just make sure it works. I'm gonna say that's tough. It's in the hard section, but I think it's easier than some of the easy challenges, to be honest. I'm gonna put it as 3. It's maybe a 3 or a 4. Nice challenge though. I hope you've enjoyed the video. If you have any questions, comments, leave them down below. Thanks.